Hello everyone, welcome to this webinar where we will be sharing our latest results regarding applications of fiberboard recycled fine particles into particle board. This is one of the research topics that we are covering in the EcoReFibre project, along many other initiatives that are being researched in this project. The EcoReFibre project aims to give a second life to fiberboard panels by means of smart and sustainable solutions. And up to date, there isn't industrial proven technologies to recycle fiberboard. And this is what we are researching in this European funded project. My name is Inês Mota. I started working at Sonae Arauco in 2023 in the research R&D department. And since then, I've been following up projects such as the EcoReFibre and also other projects that the company has in place regarding the recycling of wood and applications into our products, and also follow up other research projects regarding with alternative chemicals to be used in our products and or alternative additives. My background, I have a PhD in chemical and biological engineering, and I've worked mainly, my research was mainly focused in biomass valorization and biorefinery, more particularly in lignin valorization and extraction and separation processes. And I'm happy to share this talk with my colleague André. André, please give us a few words about yourself.
Thank you, Inês. So my name is André Mota, and despite the same family name as Inês, we are not family related. So the first question on the Q&A is already clear, for sure. I work in Sonae for 10 years now, always in the product development department. I'm a material engineer, and in my career I was always work in the sector of product development and quality assurance. Hope you like this webinar today.
And your insights will be very, very good
We hope so.
for this presentation. And so before diving into details, just to give you a quick overview of today's webinar, we will first explain why wood-based panels are a sustainable and efficient alternative towards fossil-based materials. And then this will lead us to the relevance of post-consumer wood recovery and more specifically the fiberboard recycling and how recycling fiberboard plays a key role in saving raw materials. Afterwards, of course, we are here because of the European project, the EcoReFibre, and so we will introduce to the project and explain you what are the main goals and outcomes that we want to achieve in this project. And last not least, also a very important topic of this webinar, we will share with you our laboratorial results regarding the incorporation of recycled fiberboard fines into particle board applications. And so why wood-based panels matter, and now more than ever? So wood is a renewable resource and has a positive environmental impact due to its capacity of retaining carbon. Each cubic meter of wood retains 900 kilos of carbon dioxide, and therefore wood plays a crucial role in reducing green gas concentrations and also plays a vital role in combating climate change. And additional to this, we have also other key advantages, because wood is a natural resource, and so with utilization of wood into products, we are not relying in fossil-based materials. Also, an economy based on wood exploitation and forest exploitations means that we need to use a certified chain of custody wood, meaning that the wood is regulated and we don't compromise the ecological balance, and also we will always have material available and will not compromise future generations. And this is the most important principle of circular economy. Wood is a sustainable alternative to other fossil-based materials. It's renewable, it's reusable, it's recyclable, so all aligned with circular economy. And particularly for wood engineered products, we can easily tune the products to have different dimensions, different properties. So this flexibility in design turns this type of products very, very attractive to be explored. And forests play a crucial role in mitigating climate change by acting as carbon sinks. And each year, the European forests, they retain 806 million tons of carbon dioxide, which is equivalent to 20% of the European Union fossil fuel emissions. So, in addition to this capacity for absorbing CO2, forests also helps regulate the climate, protect against natural disasters, and it's also vital to maintain biodiversity. So here we can see the importance of the forests and of a bioeconomy based in forest exploitation.
Yeah. And as Ines was explaining, wood and versus the other materials, so this benefit that wood can bring to our planet is not only that this carbon sink, but also can have this positive impact comparing to other products that are used in the market, comparing like with cement or iron or aluminium. So not only wood doesn't have emissions on the production, and to make the wood-based panel it have a positive impact, it can capture the CO2 also from the other materials. So it also brings this positive impact to our planet, acting like a carbon sink for the CO2. And also can bring other advantages when we speak about wood and the circular economy, and that is the main focus also that brings us to these projects, that is closing the loop. It's something that is very important to our industry, and not having the products handing in the consumer, and really closing the loop and bring second life to the products. The reuse and recycling of wood-based products, it's very important for the planet, it's very important for our industry. It's the way we have to extend the product life and to bring these benefits to the longest time possible. Having the minimum waste of the wood-based products. This also links to the way the products are designed. So the eco-design brings also an important role in this step. Even for the recycling of the products, the eco-design also it's very important in the way we can then try the products and sort out the materials to the recycling centers. So this is also very important, eco-design. Also, it's needed to work, and it's something that Sonae Arauco also commit in every time more efficient process and bring always the most value from the wood to our products, so that we have the minimum waste possible. This is something that we focus on, and also this awareness for the social engagement is also needed to help this closing the loop on the products. So this brings to the importance of this post-consumer wood recovery. So how it can be made and the importance that it brings to our industry and to all of us, because this is the point that we need to be more focused, and also the goal for this project is the ways that we have to close this loop. First of all, I want to try to clarify what it is considered this post-consumer wood. So post-consumer wood, it's all the types of products that have already fulfilled the life that it was intended for the first production, for the first use. So it can be the furniture that we have at our house after it have some damage that we sort out, pallets from industries or construction sites. So all these wood that have already fulfilled the first life, the conception that they were built in the first time, it would be considered post-consumer wood. And of course, because of these different applications, this post-consumer wood brings the challenge that is they are built with different materials, with different compositions that can bring with metals, plastics, coverings, coatings, different types of elements that also brings this new challenge that is how to treat this post-consumer. This is something that it's also needed to be worked on. But why is this post-consumer wood very important to us and to our industry? Is because from the data that we have seen, more than 50% of this post-consumer wood is used as energy for energy recovery. And despite it's also a good way to use wood, we want to consider that this will be the last resource that we use the wood. So giving second life, extending the life of the products will always be the best choice, and not only the energy recovery. So this is the potential that we are seeing here to use this 51% of wood that is being used as energy recovery to be incorporated in new products and giving second life. And this will also maintain this carbon sink that the products have, because when it is used as energy recovery, we lost that advantage on the wood, of course. And that's the negative impact of the discarded wood. So we stop to have this carbon sink, this capture of carbon in the wood, so it will be released to atmosphere after the incineration. So this is what we want to avoid and use it only for the last resource. And of course, the increase and of wood, virgin wood that we have in our industry and others, it also put the wood a scarce raw material. So we want to take the most profit of it and try to extend its life cycle for sure. So using the post-consumer wood will reduce the dependence that we have on virgin wood, will get lower emissions on the products and to atmosphere, and it will benefit for this circular economy, so creating these collection centers, new employment. So this is also a benefit that we have to use wood in this sense. In Sonae Arauco, from the data from 2024, so last year, we are already incorporating recycled wood in our products in the percentage of 33%. So it's an average even higher than what is being used now in Europe, that is around 25%. So we are above this level, but it's something that we want also to work even having higher percentage, because most of this percentage is used in particle boards and not in MDF, and this is where the challenge to recycle also the MDF and incorporate recycled wood also in the products that we produce for the MDF, and not only particle board. Because for particle board in Sonae Arauco we are already in levels higher than 70%, and this is something that we also want to bring to the MDF that we produce. But we have challenge for sure, and the challenge that we have in this industry is the type of technology that exists that brings a different challenge to use the fibers and to recycle the MDF and to bring this second life. The MDF that is being used now and for our particle boards we have some difficulties to remove it from the other products, for sure. So we need this evolution in the technology that is in the market to have this more efficient process. The presence of different contaminants will also be a challenge to use these products as a recycled material, and the lack of knowledge that there is still in we have seeing in the market that it need to be improved so that we can include these recycled MDF fibers in our products without having a negative impact, and even getting a positive impact on it, because for sure in these terms of extending the life cycles of the products will improve our planet. And why is this needed? Well, at this time, the production of MDF is increasing. It's a good sign. So the wood-based products are being have higher demand at this moment. But that also brings higher material being wasted. And so that brings the need that we need to recover also this MDF that is being wasted and discarded to landfills and to energy recover, and put it in different products, in new products, and try to extend this life cycle. So the sorting and recycling technologies for the MDF, it's very important and very needed for our industry.
And André, that is why the project EcoReFibre was created and was born, because through the figures that you show us today, the fiberboard post-consumer waste is growing exponentially, and there are still a lack of industrially proven technologies to recycle fiberboard again into fibers to be incorporated into the same product, to similar product, maintain the value of the fibers. Not using it for energy. Of course, as you said, we need to produce energy, but it's important to maintain the carbon retained and to maintain the value of the fibers. And so the EcoReFibre project, it's a European funded project that counts with the participation of 20 entities. The project started in 2022. It's a 4-year project, so we are in the finishing line, getting ready for the industrial demonstrations. So the main goal of this project is to develop and demonstrate innovative technologies to find viable solutions to recycle the end-of-life fiberboards. And what is the value proposition of this project? It is intended to allow the utilization of fiber through cascade applications, therefore ensuring that the fibers remain in the loop, and that we close the loop. Also, this will allow us, since we are maintaining the carbon retained and will not emit to the environment, so we can kind of produce a fiberboard with less carbon footprint. And most of all, with these initiatives, we are guaranteeing that we can continuously recycle the fiberboard materials that we are putting into the market. And this finally and consequently, of course, will help us to reduce the dependence on virgin wood. And so together, these advantages, they help create a fiberboard production system that not only is more sustainable and eco-friendly, but also brings benefits to manufacturers, to consumers, to the environment. Also, the benefits that it brings, can have a very important impact into our economy, into our planet. And here is just to give you the picture of the multidisciplinary consortium that the EcoReFibre brings together. So we have industrial players, we have research institutes, universities and associations working together in a common goal, that is explore different recycling pathways for giving a second life to fiberboard. And how is the project organized? So the project is structured into integrated work packages that cover technology and pilot demonstrations. In the first work package that is related with waste provision, we are conducting market survey studies to try to understand what is the type of wood waste that we have, and also to find the best way to sort and to clean the wood to pursue to the next stage that is covered in the work package 2, related with the recycling processes to be applied to this post-consumer wood, and to produce again new recycled raw materials to be incorporated into products. And so next, in the work package 3, we are researching and demonstrating products, into products, turning into life the recycled fibers and fines that are produced into products. So it is expected to make demonstrations in Particleboard, which is the main topic of today's webinar. We will be sharing the results related to these prototypes, but then we also want the project also wants to demonstrate the applications into novel biocomposites, or introduction of these recycled fibers into new fiberboard panels and insulation panels. And these 3 work packages, they are assisted by Met4, which is a company that is applying machine learning to acquire data and to assist in the optimization and into understanding the results and all the data that the project is processing. And also correlating to these activities, we have the work package 4, where we are conducting sustainability assessments, evaluation of economical feasibility, because in the end we want to develop a sequence of processes where we can contribute for a better planet, but also it has to have an economical return. And so what are the main outcomes that we are expecting to have with this project? So we want to scale up technologies, process of combining recovery of wood, sorting and recycling the end-of-life fiberboards, and demonstrate it in an industrial scale. For that, we need to do also demonstrations in an industrial scale. So we are now in the stage of finishing the laboratorial tests regarding Particleboard, MDF, HDF, insulation boards, or even the novel biocomposites, and then we'll move forward to increase the production. Go to industrial scale, and this we intend to strengthen the competitiveness of the sector and really resilience of the fiberboard chain, and also obtain environmental, economical and social positive impacts.
And as Inés was referring, so part of this project, it's the incorporation of these fiberboard, fine particles into the Particleboard. And before going to the data that we had in this project, we thought that it would be good to explain a little bit how it works, the process to produce Particleboard, to understand the challenge that we face to incorporate different materials in this type of products. So particle board is a wood-based material, engineered wood-based material that can be with single layer or 3 layers. So the most common product in the market is a 3-layer particle board with 2 external layers with thin wood particles and 1 core layer with longer and thicker wood particles. Of course, depending on the way we produce the board and the way we produce the particles also for the product, we can have different types of properties and classification. The particle boards can be classified in Europe as P1, P2 until P7 is the standard from European Union. And these can change depending on type of wood that we use, type of particles, and also the formulation that we have into the process. To make this as a product with wood, we use it with adhesives, normally urea formaldehyde resins or melamine urea formaldehyde resins, depending on the type of application, emulsions, and hardeners also in the formulation to have these adhesives on gluing the particles together. The change and the mixture between all of these can have different properties on the finished product, and depending on the application that we need to change and focus to the application. And this because the particle boards can be used in the furniture that we have in our houses, like cabinets or shelves or our beds or tables. For interior design, so wall panelings and decorative for the construction or industry applications, but also for decorative panels. When we put it with paper or foil faces in both faces of the particle board, we can use a different type of decors and finishings with veneers or laminated or even lacquer PP. So these different applications will lead us to different ways we need to produce the particle board, and in production also with the different process that we can influence the board, we can have different properties. And how it is made, the particle board, so we start with the raw material. And this is a very important step for our products, because it is when we guarantee that we have quality raw material, that we guarantee the quality of our finished boards. It's like doing cooking at our houses. So if we use good ingredients, for sure we can have a good dish at the end. So in our products also the same. So we need to guarantee this control of the raw material is very important. In this, when we use recycled material, the importance is even higher because the variability that we can have in the raw material is higher. So this control and guaranteeing that we only pass wood into the process, it's very important our step when we use recycled material. So the sort out, the cleaning of the wood that we receive from our collection centers that we have, it's very important to guarantee that is in perfect conditions. So after having this sort out guaranteed and controlled, we move out to the drying and classification of these particles. Because in this step we need to be sure, and as I explained before, the particle board can be produced with thin particles and thicker particles, so we need to segregate them and separate to different parts on the process. So is this a very important process that we need to have the characterization of the product at the end. After this separation, we have the process of bending, and this is also very important because it's here that we will guarantee the homogeneity of our boards. So guaranteeing that the blending it's made always in the same step with the same rate. So the speeds, the quantity of glue that we introduce together with the particles is very important in this step to guarantee that we have all the particles embedded with the resin, so we have a good reaction. After this, we have the matte formation, so we start to put the lower surface layer in the matte, then the core layer, and we finish the product with the upper surface layer before the press. So we have the matte being done here with higher thickness that will be going to the press, where we use temperature, pressure, and time to make our products aboard. So it's here in this step that the product is transformed in wood particles to a real board. In the year, the most important factor is to control that we have the time to allow the resin to cure and to have the homogeneous properties along the board, and to have always the same thick of the board that it is desired to the product. After this, we can control some properties on the product, but very few more related to the surface and appearance and dimension. So we cut the product. We can have different finishing on the surface, so different sandings that you can have depending on the application of the product. Then it's the packaging and expedition and our quality control to guarantee that everything that we have done in the process, it was in accordance to what was intended to.
Yeah, and so this explanation of the particle board and the process of production of particle board is important to introduce the approach that we research in the EcoReFibre project. We are talking today in a particular task of the European project related to DMOD with the fiberboard fines application into particle board surface layer. So the main goal of this task is to demonstrate the technical feasibility of introducing these recycled fibers as fine particles into the particle board surface layer. And to address one question, that is the shortage of sawdust. Typically nowadays sawdust is used in the surface layer to improve surface properties, but due to fluctuations in price and sometimes in shortage of this raw material, it's important to find other alternatives that could also bring the same benefit as sawdust. So therefore, in this work, the expected benefit of introducing these fines. So during my presentation, I could mention fines as to, I'm referring to recycled fibers, fine particles that we are producing in the project. And so we expect by introducing this into particle board to have a more circular product, because we are introducing more recycled wood into the product, and also alleviate the shortage that we have in the sawdust, and enhance simultaneously the particle board surface properties. And in the end, the value that we intend to present is to obtain a differentiated product to the market with smoother and more close surfaces that where we can use for furniture and decorative applications. And how are these fines produced? They are produced by innovative technology that is being developed by Diefenbacher. So the post-consumer fiberboards, they are collected, they are shipped, clean, sorted, so in order to have a rich fraction of fiberboard chips, and then through innovative technology that we call a dry impact reactor, which is a dry process where the fiberboard chips are converted into fine particles. And these fine particles are afterwards screened in order to obtain a homogeneous distribution of particles, and this will help us to control the process in the next steps. And so we take these particles to be incorporated into particle board. But first, one of the first things that we did in the lab was to conduct a granulometric distribution of the fines that we were producing. and compare it with our typical industrial surface layer particles and also sawdust. So in the graphic you can see in orange and green are two examples, two of the batches that were produced by the Dieffenbach's technology. So two different batches of fines. And in gray and in black we can see our comparison sources, which is the surface layer particles and sawdust. And the main conclusion and the main observation that pops out from this evaluation is that the recycled fine particles that we are producing in the project, they have a considerable amount of particles below 0.5 millimeters, so very small particles. And also in the right side, we are displaying the typical industrial surface layer particles that we have in Particleboard, and below we have the recycled fiberboard fines that we are producing. So we can visually see that the particles that we are producing, they have a granulometric aspect, and also geometry different from the typical particles that we employ industrially. So we took these fines, and we produced particle boards in the lab, 3-layer particle boards. We maintained the core layer standards, and we only replaced 10, 20 or 30% of the surface layer industrial particles by these fines. So we did not add these fines on top of the surface layer. So we remove 10, 20 and 30% of the surface layer industrial particles and blend it with and replace it by the fine particles produced in the project. And then we blend the particles and we glue with our standard recipe and produce the laboratorial panels. In the lab, we studied the influence of the resin load, and also played a little bit with different granulometric fractions to evaluate the effects. All boards produced, we evaluated physical and mechanical properties to help us understand the main outcomes of the incorporation of these fines into particle board. And so here first we present the results regarding internal bond at the left, and at the right the thickness swelling of the particle boards produced. We produced always a reference with no fines, 0% incorporation of recycle fines, and then we have the incorporation of 10, 20 and 30% recycle fines. And the main conclusion of these two parameters is that we did not see a significant impact in these parameters, in the internal bond and in the thickness swelling. Of course, we did not change the core layer, which is mainly responsible usually for internal bond property. But since we were changing the surface layer, sometimes changes in the surface layer can affect density profile and indirectly affect internal bond. But here what we observe is that neither internal bond or thickness swelling were significantly affected, which was a good outcome. Then we analyzed our panels regarding bending strength. And surprisingly, we saw that for incorporations of 30% rate, we had good and great improvement in bending strength. which was a very interesting result to see. At the left, we are displaying our results regarding surface soundness of the panels produced in a raw particle board or surfaced surface. And regarding surface soundness, we did not see a significant impact in this property.
In this case, we can say that well, no difference is also a good result, no, because we are already incorporating the 30% of recycled fibers fines, so it's already a good impact, and we can see also in the bending strength that incorporating 30% of recycled fines, we can also have better behavior. So it's a double win. So we incorporate recycled material and really improve the properties on the product. So in this, and having no impact is already good, but having improvement is much better, no?
Yeah. So you're right, André. This, although we were expecting to see something surface soundness, this is a positive result that what we are seeing here, with the additional advantage of improving the bending strength. Yeah, definitely. And then we also analyzed our boards, our laboratorial boards, regarding surface ruggedness. And this property was very challenging to evaluate in the lab, particularly for the incorporation of 30% recycled fines, where we can see that we have a wide dispersion of the results. So it looks like our boards that we are producing, they confer a very heterogeneous ruggedness. Maybe since we are making the panels in the lab, they are handmade, could we have been distributing well these fines into the surface layer? So it could be one of the reasons explaining this variation in the results.
That's something that will be also important to evaluate in our industrial trials. So we can see, because the equipment will be different, and we have ways to guarantee that it's the particles that we are incorporating in the product is well distributed. So in this sense, it will be very different of what we can do in lab scale for sure, and also it's the outcome for sure will be different. No?
Yeah, we really hope so. We really hope, and that's why the industrial trials will be important, because probably in the lab it's very difficult to evaluate surface soundness and ruggedness. Sure. So you really need to go to industrial trials and to see if we, with our typical industrial setting, we can have a more homogeneous surface that could, and see the real benefits of introducing the recycled fines. But also we in the lab, we conducted cutting performance studies, and at the right graphic, we are displaying the edge quality of the analysis of cutting performance, where we can see that the incorporation of these recycled fines has improved the cutting, the edge quality of the boards produced. This means that with introduction of these fine particles, operations like milling, drilling, cutting, they will be improved for sure. For at least was what we observed in the lab. So, as the main outcomes of this project, we successfully demonstrated that we can incorporate these recycled fiber fine particles, and they can be reused in particle board without compromising at least the physical mechanical properties. And also another thing that we saw but not shown in the slides before, is that we don't have the need to change the gluing recipe. So we can incorporate these recycled fines and still maintain our typical gluing recipe to produce the panels, which was also a good outcome. But also interesting to see, although we did not see it in surface soundness measurement or ruggedness measurement, the truth is that when we take the panels and we observe them closely, we observe that the surface, the fine particles, they are covering very well the particle board surface. So this for sure is improving the surface layer of the particle board. But there are some things that we cannot simply measure in the lab, like the behavior of these fine particles that we are producing in the project, that you can see in the picture that is presented, how it will be the behavior of these fine particles in an industrial process, like in steps like sieving or during matte formation. Matte formation is a dynamic process. So how will these fines behave in a real industrial processing? Again, this leads us to the answer that we really need to go to industrial trials, but of course some stages of our industrial process will be of concern. So as upcoming actions, we are already discussing the industrial trials with the plants, and in order to demonstrate the industrial feasibility and scale up of the technology that we are developing here for the particle board. And of course we will conduct a deep characterization of the boards produced, and particularly in surface quality, in order to check if and prove that we can have improvements with this incorporation of this type of particles, because the intention is to produce a differentiated product. And in the end, money is always important for the company, so and also so we have to conduct economical assessment, and also the technology has to be scalable, has to be easily integrated into our process. So we will be analyzing the feasibility and combination of technical, economical, and sustainability to determine the possibility of implementing this in the future. And to wrap up this talk, this webinar, we conducted a kind of a SWOT analysis and identified strengths, weaknesses, opportunities, and threats for this particular task of the EcoReFibre project. And one of the strengths that and most important strength that we identify is that we are really doing something truly innovative that could actually enhance the surface quality of the particle board. This is the main strengths that we identify with this approach that we are studying. But on the other hand, there are weaknesses that we need to address. So the technology that is being developed by Dieffenbach, it requires initial investment, and so we really need to assess this and to carefully plan and verify if we can have a viable, economical viable solution with this, the implementation with this technology. And also, we still don't know what type of adaptations we have to do to our industrial process in order to incorporate this recycled fiberboard fine particles into our process.
Yeah, and as for opportunities, we can see a lot of good things. We have only put here some, but the type of differentiation that we could make in our particle boards in terms of the surface, the finishings, that for sure it will bring added value to our customers and the different possibilities that they could have, and when they can produce with this type of products. And this will be a very good opportunity. This closing the loop that we talked before, that is very important. So closing the loop on the recycle of wood-based materials, this will be very important, and to take advantage of the MDF that we have now being wasted and transform it in different products and new products, even with higher added value for sure. And also, as you spoke before, Inês, the scarce of the sawdust that we have now in the market and higher prices is leading us to different ways to try to produce with particle board, but this could somehow replace the sawdust that we so need for the quality of our surface for our products. Of course, also threads come along. I would say that they are more challenged than thread. So, of course, if we see that most of the MDF now it's being wasted and go into landfills or incinerated, we have to conduct ways to collect it and separate it, to transform it and to put it in this cycle. For sure, that will be a challenge for the future. And because the products are made with different other materials, as we spoke before, with plastics, metals, and so on, this sort out of the products of MDF will be also very important. It will be a challenge for sure, but with these new trends of some companies also having the eco design in the product, so having design thinking, trying to put it easy ways to sort out the products, and that will also help in this thread, we hope so. So in these threads, it's some small challenges that need to be solved, but I think it's feasible and the value that we can have it is, it's much higher than this, yes.
Yeah, and definitely, and although we have these challenges and weaknesses to address, the potential of and the opportunities that we foresee for this task in EcoReFibre project, they are exciting. So let's see in the industrial trials how we will come out. So definitely the industrial trials will make this idea, this concept will be turned into reality, and we are really looking forward to test it in a higher scale. So we hope that you think that this presentation was insightful, and thank you for your attention.
Yeah, thank you. It was a pleasure to be here with Inês. If any question you have there, the contacts also, but we can also have here Q&A time. We still have some minutes, so if you have some questions to put. Okay, I see that we have already some questions. That's a good thing.
Yeah. So the first question that are asking us is, did you change anything from the resin standpoint while doing the recycling? So resin standpoint during particle board production or recycling. So we have two things to think. Of course, the products, wood-based products, they have resins, and during recycling, some of the resin will be hydrolyzed, but most of the resins will be placed in the will remain in the fibers. So we will always have some traces of resin in the recycled fibers. And regarding the particle board production in laboratorial, as I said during the presentation, we did not show here the results, but of course we tested a higher resin dosage to see the effects, if we could improve thickness swelling, or even further the internal bond or surface soundness. We could see positive effects in surface soundness, and we did not see any changes, meaning that the process, that's the standard process that we are using today, will be suitable for this product.
Mm-hmm.
So now, do you want to read?
Yeah. So the question now is regarding this bending strength improvement, if it was visible in the same range of density in all the samples that we made.
Of course, yes. So I did not mention, but it was in the presentation. So all boards produced in the lab, they had similar densities. So this bending strength was probably related to fines, but a good point to check. But in general, we have the variations of 10 kilos, so I believe it wasn't too much, and the effect in bending strength was higher, significant.
Yeah.
So did the resination of the fines and surface layer particle were in the same lab mixer? Yes. So first we blend the surface layer and in the fines, and they were glued together in the same mixer, so using the same recipe.
That's also a good sign that in the industrial trial there's no need to different equipments, and well, that's what we assume, so no need of do it in this separated way. So it's also a good point to do it together, and that's the added value to put it all together.
Yeah, if the fines behave well in our typical sievers and system, so this will be very easily implemented in an industrial scale. Yeah. So do you want to answer this?
So the question is, what impact does recycling have in the environment? And when we speak about wood-based products, it have an even higher impact, because, well, recycling have a very good impact in the environment in all the products, for sure. So extending the life cycle for products is even better for all. But when we speak about wood-based products, the recycling, and because the properties that we have and the wood work as a carbon sink, so it maintains the carbon inside it until it is a product. So it's the longest we extend the life of wood-based products, we will still maintain the CO2 inside the product. It's only when we burn it we emit the CO2 to the environment. So in terms of wood-based products, it have a very good positive impact in the environment. As we said before, even it will benefit for other products, because 1 ton of wood can maintain 2 tons of CO2. So it's a very good impact, let's say.
Yeah, definitely. And wood-based products, they are increasing, the importance and the relevance is increasing, and they are being attractive for applications in the construction sectors for several materials. So also if we only rely in virgin wood source, that would definitely wouldn't have a sustainable economy. So recycling is very important to maintain the balance, the environmental balance. So any tests how the panels are behaving to sanding versus standard PB. So this is one of the properties that we hope to evaluate better in the industrial trials, because we do sanding in the lab, and actually our sanding, we have a machine, a calibrated machine in the lab, so it's not hand sanding. But still, we believe that we have limitations in understanding the sanding properties during in a laboratorial scale. So definitely we need to go to industrial trials to see this behavior.
At least for the first insights that we have from the lab scale tests, we see that it seems to improve and to close the surface. So in terms of sanding, will be similar to what we have for the standard PV, but at the end we will have, and what we seen in these lab scale tests, we'll have a more closed surface with the fines, putting the surface even better for different applications. Yes.
Yeah. So you mentioned recycling fiber to PB. How about fiber to fiber next webinar? Yeah, probably the next webinar, also in the EcoReFibre, we are researching, and so this is one small task of the EcoReFibre projects. We have many other tasks related with fiber recycling and incorporation into new fiberboard products, and that's the challenging that we have. So because so far we don't have viable technologies to produce recycled fibers and to incorporate them into fiberboards again. And so it's important to research this. And also, of course, this particular demo that we talked today, it's important to find alternative uses to recycled fibers.
Okay, so I was very happy to see that we have a lot of questions in the loop, but well, for timing questions, we need to wrap up. It was really a pleasure to participate in this webinar. Thank you for the invitation for this. Hope you had liked it.
Yeah, and thank you for your questions and for your interest in the topic. Actually, it is a very important topic. That it's important that in the near future we have projects such as EcoReFibre and fiber to fiber, to address these questions and to find suitable technologies to recycle fiberboard and remain the fibers into the loop. Thank you for your assistance.